Today's lecture, we're going to look at prime and composite numbers. Example 1, we're going to see if following statement is true. What does this line mean is this number is dividing 86 evenly without getting a remainder, right? So let's see, does 4 goes into 86 even without the remainder? Well, we can tell if we divide it. 86. Four goes into 8 twice, and then bring down 6. 4 goes into 6 one time, where you have remainder of 2. So this one had remainder. So we say this statement right here is going to be false. 4 is not divisible of 86. So 4 cannot divide 86 without the remainder, right? The next problem, B, is asking 9 is not divisible 81. So is that true? Let's say 81, we're dividing with 9. We know that 9 times 9 is 81, where your remainder is 0. So we should be able to write it as 9 dividing 81, right? But because we had not sign right here, it means this statement right here is also false. So what about the next one? Does 8 divide 840 without the remainder? So let's try 840 divide by 8. Goes in one time. Bring down 4, but 4 is smaller than 8, so bring down the next numbers, which is 40. So then 8 goes into 40 5 times, which is no remainder. So this is true. Example 2 is asking you to find the prime factorizations. Factor means showing your number with multiplications. So for example, 45. If I wanted to find prime factor, I need to find the prime value first inside of 45. So I'm going to use the factor tree. So this is a branch out from 45. What two number multiply to become 45? And I want that first number to be prime number. So prime number is 5. Goes into 45 9 times. Another word, if you're multiplying 5 and 9, you get 45, and first number is prime. So we don't have to factor any further because prime number, you're going to have 1 and itself as the prime. A factor. That's the definition of prime factor. 9 is not a prime number. So if it's not prime number, then I'm going to branch out further until I find all the prime numbers. So then 3 times 3. And 3 is prime number, and both number is prime. So what's left here? 5 times 3 times 3 will be 45. And that's your prime factor for 45. And you should be able to write it as 3, because you have 3 squared times 5 as your prime factor. Let's try that one more time with 120. 120 even numbers. I will always start with 2 because 2 is the smallest prime number. And even number always 2 fit in, right? So 2 goes into 12, 6, and you had a 0. So 2 times 60 is 120. 60 is another even number. So if I factor 2 out, that will be 30. 2 times 30 is 60. And that's 3. 3 times 10, that's 2 times 5. So your prime number prime factor of that number is at the end of the branch. So that's what you have. How many 2 do you have? I have 3 2, and I have 1 3, and I have 5. So if I multiply by 8 times 3 times 5, or 2 cubed times 3 times 5, I will get 120 back. And we call this is going to be prime factor. Factor is, again, multiplication of the number is the factor. Because it's a prime, your value should be all prime numbers, right? 2, 3, 5 is prime. Example 3, we're going to find greatest common divider. So in order to find greatest common divider, we're going to, again, use the factor tree. So this is going to be 5 times 5, both number being prime, will be 5 squared. That's how you can write it, right? And for 70, it will be 2 times 35. That's 5 times 7. So 70 is 2 times 5 times 7. So we're looking at prime factor from both number. In order to find greatest common divider, find the overlapping values. So this number right here, you have 2 5. These numbers, you have 1 5 and 2 and 7. This number have 2 and 7, but this number don't have 2 and 7. So you're not going to use 2 and 7 because the value you wanted to use to multiply to find greatest common divider is common value from those two. So from these two number, common value is just 1 5. So you're going to have 5 as greatest common factor. Greatest common divider. Let's try another one. 6 is 2 times 3 and 3, 33. And then 3 times 11. So you get 2 times 3 times 11 as your prime factor for 66. Prime factor for 90 is 2, 45, and then 5 times 9 and 3 times 3. So it will be 2 times 3 squared times 5 as the prime factor for 90. In order to find the greatest common divider, find the common between these two numbers. So look like both prime factor have 2 and then 1 3. No 5 here, no 11 here. I have 1 3, 2 3, so just use the 1 3, right? It will be 2 times 3, which is 6. So 6 is going to be your greatest common divider. Example 4, this time we're looking for least common multiple. Well, least common multiple is going to be very similar to greatest common divider, but last step will be different. So we will use the factor tree. For both value. So it will be 2 times 5 times 7. And when you're finding least common multiple, now you're going to use all the prime numbers. Where the other one, we're looking for greatest common divider, you use the common value, right? Here, you use all the factor. So I have 2, and I have 5, and I have 7, right? And if you have the same number, here I have same number, right? Same number. Then you're going to use the one with the higher exponents. Don't forget the other one. When you only use the one with the common values with the smaller exponents, but least common multiple, all the prime, and one with the higher exponent. So this is going to be square. So least common multiple of this two number is going to be 2 times 5 squared times 7, which is going to be 350. Let's try one more time. So we find the prime factor. So 72, 2 times 36, that's going to be 6 times 6. I'm trying to show you no matter what number you get of the multiplications, if you factor all the way to prime number, you're going to end up getting same factor, prime factor. So that's going to be 2 times 3. This is 2 times 3. So 72 is 2 cubed times 3 square. 120. Instead of using 2, because that's what I will usually do, what about if I use 12 and 10, right? 12 is not prime, so I need to find the prime factor of 12, which is going to be 2, 6, and 2, 3. 10, it will be 2, 5. So combining all those prime multiplication, I get 3 up 2 times 3 times 5. So least common multiple is going to be all the prime number with the highest exponents. Both of them are cubes, so I will use cube. I have 3 and 3 squared, so I will use 3 squared. And when I multiply that, 360. Example 5, we have word problems. So it's okay that you need to read the word problem 2-3 times to understand better. You need to divide 40 men and 24 women, you're dividing, okay, into all male and all female teams, so that each team have the same number of people. What is the largest number of people that can be placed on the team? So basically they're asking for what will be the greatest common divider. So they're asking you to find greatest common divider. And we have 40 and 24. And find the factor, prime factor first. So it will be 10 times 4. 10 is 2, 5. 2 is 2 and 2. All 4 numbers prime numbers. So you have 2 cubed times 5 for 40. 24. 2 times 12. 2 times 6. And 2 times 3. So 24 I have 2 cubed times 3. In order to find greatest common divider, you find the common value. So that's going to be 2, and both number having a cube. So 2 cubed, which is going to be 8. So 40 men can have 5 teams with 8 men's teams. We can have 40 men can forms 5 teams with 8 men. And then 20 4 women can form 3 teams with 8 women. For these questions. Example 6. A movie theater runs its film continuously. One movie runs for 80 minutes and the second run for 120 minutes. Both movies begin at 4 p.m. When will the movie begin again at the same time? So this problem, you're looking for least common multiple, right? So we have 80 minutes movie and 120 minutes movie. We need to find the prime factor. So 80, I have 2 to the 4th times 5. 120, 10 times 12, that's 2, 5, that's 2, 6, 2, 3. So you have how many 2? 3, and then you have 3 and 5. So your least common multiple of those two numbers is going to be 2 to the 4th times 3 times 5, which is going to be 240. So this problem you will have after 240 minutes, or that's 4 hours, right? So after 4 hours, the movie will be started at the same time.